sigma F equal ma if V is not constant. Basically, that was what we studied in the previous class. In addition, we learned that on the coordinate system. So we said that in order to solve a problem, when we have to find a particular force or acceleration or anything that deals with dynamics other than the force of gravity, because the force of gravity is very simple and g, so we need to follow the certain algorithm, which is the first instance you set up the question, what is given and unknown. 2, you draw the row diagram of the situation. 3, you draw the FBD, which is the force body diagram or free body diagram, which is more specific than the row diagram. 4, you find which Newton law between the first and the second, you choose which one you will use to be used and along which axis. So depends on the question, you will use either along X, along Y, or along both. Number 5, you find the algebraical addition of all forces on the desired axis. 6, substitute and calculate. Then 7, it will be just the answer. This is pretty much the algorithm to solve a complex problem applying the Newton laws. For example, I did one last week with the Newton first law, which was the traffic light hanging with no wind, nothing affecting or moving the object. And the second one, applying the Newton first law and Newton's second law, was when we found on this problem, I asked to find without friction at that instance. I gave the force, I gave the angle, and I asked find the acceleration and find the normal force. You can label N capital or Fn, doesn't matter. And I gave the mass of the object. That was the problem? I asked to find acceleration. I finished that problem, right? Yes. So I found the acceleration and I found the Fn. Going over the steps you need to follow. Here pretty much is the setup. I mean, I have the angle, I have the force, I have the mass, and I am looking for this. This is step number 1. Step number 2, you draw the forces acting on the object, but rolling, not necessarily specific. So what other forces are acting here? You know that is normal force, and you know that the gravity is also acting here, assuming that there is no friction. This is a row diagram. The free body diagram is a little bit more specific. There, in the free body diagram, you specify the direction of motion, and that will be your positive. How? With an arrow. You put the object, which is the system and the study, in the center, and then the forces of the origin acting F, Fg, Fn. And you include also components if you have a force at an angle. This force is at an angle, I will include the components Fx, Fy. Now, this gives you a better perspective of what is going on in the problem. So what forces are along X and what forces are along Y. The next step is to find which Newton law we will use and along which axis. That's very simple. If it's moving and I am looking for the acceleration, which Newton law? So you have to choose between the first and the second. If it's accelerating, which of the two? The second law. And then along which axis? Oh, it's moving along x, so the acceleration is along x. So I will say net force along x equal ma. This is my choice. This is that step. And then I have to disclose what is this, which is the next step. Find along, the algebraical addition of the desired, addition of all forces on the desired axis. So I know that is along x. I just look at what is going on along x. And the only force that I see along x, in this particular case, is Fx. So Fx is the only force, the component of the force along x equal ma. If I am calculating for A, will be just the force cosine theta, which is the x component, divided by the mass. This will be how to find the acceleration. Of course, I can change the problem. In the study guide, I gave 2 forces instead of 1. I can, instead of pulling, I can push the object. So those are differences that you can know. All right. After that, you just substitute and calculate. This is the algorithm you will follow for all complex Newton laws. Where you apply Newton laws problem. Newton laws law. Newton law. Okay. Then I ask for the normal force. Is the normal force along x or along y? It's along y. What will be the algebraical addition of all forces along y? Fn minus Fg plus the y component here. And from there you find the normal force. That's it. This was the problem, the last problem. Okay. So another problem, applying the Newton laws, is when I can ask for example, in an elevator, there is an object, there is a person, and there is a scale. This is the scale in the elevator. And there is a person. So I can ask what is the apparent weight. Apparent weight is the same than the net normal force, the magnitude of the net normal force exerted by the supporting surfaces. Can be 1 or can be 2. In this case, it's only 1 supporting surface, which in this case, on the person, is just the elevator. So the elevator, the scale. The scale is acting here, not the elevator. Only the scale is acting on the person. So if I ask, if I give the mass of the object, for instance, let's say it's 60 kilograms, I can ask, find what will be the apparent weight on the person. Apparent weight is the magnitude of the net normal force or net force exerted by the supporting surface. This is the definition of apparent weight. Or what is the reading on the scale will be the same. Find the normal force. So find the reading on the scale, or find the net force exerted by the supporting surface, or find the apparent weight. So when you enter to an elevator and you go up and the elevator is fast, accelerate, fast, how do you feel? Heavier or lighter?